Welcome back to Mining of Massive Datasets. We're going to continue our lecture on MapReduce and take a look at the MapReduce computational model. So before we look at the actual MapReduce programming model, let's do a warm-up task. Now imagine you have a huge text document, maybe terabytes long, and you want to count the number of times each distinct word appears in the file. For example, you may want to find out that the word "the" appears 10 million times and the word "apple" appears 433 times, right? And some sample applications of this kind of toy example in real life are, if you have a big web server log and you want to find out how often each URL is accessed, that could be a sample application, or you might be building term statistics for a search engine. Right? So, but for now, let's just imagine that we have this one big file that's a huge text document, and our task is to count the number of times each distinct word appears in that file. So let's look at two cases. The first case is that the file itself is too large for memory, because remember we said it's a big file. But imagine that there is a few enough words in it so that all the word count pairs actually fit in memory, right? How do you solve the problem in this case? Well, it turns out that in this case, a very simple approach works. You could just build a hash table with the index by word, and the hash table for each word will store the count of the number of times that word appears. So the first time you see a word, you initialize, you add an entry to the hash table with that word and set the count to 1. And every subsequent time you see the word, you increment the count by 1. And you make a single sweep through the file. And at the end of that, you have the word count pairs for every unique word that appears in the file. So this is a simple program that all of us have written, many times in some context or the other. Now let's make it a little bit more complicated. Let's imagine that even the word count pairs don't fit in memory, right? The file's too big, it doesn't fit in memory, but there are so many words, distinct words in the file that you can't even hold all the distinct words in memory, right? Now, how do you go about solving the problem in this case? Well, you could try to write some kind of complicated code, but I'm lazy, so I like to use Unix file system commands to do this. And so here's how I would go about doing this. So this is a Unix command line way of doing this. Here the command birds is a little script that goes through doc.txt, which is a big text file, and it outputs the words in it, one per line. And once those words are output, I can pipe them to a sort, and the sort sorts the output of that. And once you sort it, all occurrences of the same word come together. And once you do that, you can pipe it to another little handy utility called unique. And one of the nifty features of unique is the -c option. And when you do unique -c, what unique -c does is it takes a run of the occurrences of the same word, and it just counts the occurrences of the same word. So the output of this is going to be word count pairs, right? So I'm sure many of you have done something like this. And if you've done something like this, you've actually done something that's like MapReduce, right? So this case actually captures the essence of MapReduce. And the nice thing about this kind of implementation is that it's very naturally parallelizable, as we'll see in a moment. So let's look at an overview of MapReduce using this example, right? So the first step that we did was we took the document, which was our input, and we wrote a script called words that output one word to a line, right? And this is what's called the map function in MapReduce. The map function scans the input file record at a time, and for each record, it pulls out something that you care about. In this case, it was words. And the thing that you output for each record, you can output one or multiple things for each records. And the things that you output are called keys. Okay? The second step is to group by key. And this is what the sort step was doing. It grouped all the keys with the same value together. Right? And